So in this video we will be doing the final review of the division method for rules of exponents with lots of practices. Okay, let's start with problem number 1. Okay, we have here is 12ab over negative 24a cube b square. So as always, first we see that whether we can simplify it within the first given problem in the first step. So we have 12 times 1 is 12, 12 times 2 is 24. So now we just write the remaining variables and numbers. We have ab over negative 2, don't forget the negative, this negative sign right here, negative 2a cube b square. So now we have to see what we can simplify it. Now a cube b square, these are both bigger in the denominator, so the subtraction for division will happen in the denominator. We simply write 1 here, negative 2 a cube minus 1, because this 3 comes from this one and negative 1 comes from this one, because we don't write 1 as an exponent power because it's simply given. And for b, we have b square in the denominator minus 1, and we get 1 over negative 2 a square b, and that is our final answer. Let's take a look at the second one. It will be a little bit different. Okay, we have negative 15 x y cube over 45 x to the power of 6, and y has the power of 3, or y cube. Okay, so again we will simplify it. Here in the first step we have 15 times 1, 15 times 3. Then we get negative x y cube over 3x to the power of 6 y cube. Okay, and now you can see x is bigger in the denominator, okay, and y is same. So when any base is same, they simply cancel out and they get a 1. Okay, so in the top we get negative 1 over 3, x has the power of 6 minus 1. Okay, this is 6 minus 1, and we get negative 1 over 3x to the power of 5. Okay, now the problem number 3 we have is a has the power of 5 and b has the power of 6 over a to the power of 5 and b has the power of 6. Again we get same thing, they cancel out and we get 1. Okay, however, I'll give you one more problem. Okay, in this one we have negative 13 x to the power of 5 y to the power of 6, and we have the same thing in the denominator as well, but we have a negative sign in the numerator, so everything cancelled out, we get 1 and the negative sign as well. So the answer for this one will be negative 1. Okay, so I want that you do one of this problem, and if you can do this it will be great. So we have negative 27 x to the power of 5 y to the power of cube, or 3 y cube, z over 9 x to the power of 3 y to the power of 6, and z has the power of 2, or z square. So I want that you pause this video and try at least 1 or 2 steps. First try to solve it right over here, and then write the remaining parts of the problem over here, and come back and play the video and I will explain you. Okay, So I hope you tried it at least one step. So first we have over here some numbers. We will try to simplify it within the first step. We get 9 times 1, 9 times 3. Again, negative 3. Don't forget the negative sign. So we get negative 3 x to the power of 5 y cube z, and over we get x cube y to the power of 6 and z square. Again, I simply wrote the same thing over here except the numbers. Numbers I already simplified. Okay, so for this one, now we cannot do nothing about the negative 3 because it's already simplified. And now we will look at x. X is bigger in the numerator. X has the power of 5 and the denominator has the power of 3. So the subtraction will happen where the power is bigger, which is the numerator. We get x to the power of 5 minus 3, and then y and z both are bigger in the denominator. Their power is bigger in the denominator, so subtraction for them will happen in the denominator. So we write over y to the power of 6 minus 3 z to the power of 2 or z square minus 1. And we get for this one again negative 3, no change with that, x to the power of 2 x square over y cube z, and that is our final answer. Okay, so let's take a look at one more problem. It will be also complex with numbers and 3 more variables. Okay, so we have negative 51 x to the power of 6 y to the power of 8 z to the power of 12 over 17 x to the power of 3 x cube y to the power of 8 and z to the power of 7. Again, don't be afraid with these big numbers or big exponent powers. The steps are still the same. Try to solve it within the first step, okay, and then base by base try to solve this problem wherever the exponent has the bigger power, whether it's the numerator or the denominator. Okay, alright, so I hope that you tried yourself. So I will solve this problem now. So in the first step we can see 51 and 17. 51 is divisible by 17, so 17 times 1 is 17, 17 times 3, okay, that is 51, and don't forget the negative sign. So now we simply write the numbers and the remaining variables. We have negative 3 x to the power of 6 y to the power of 8 z to the power of 12 over x cube y 8 z 7. Okay, and in the next step now we will solve for x, y and z for the variables. First we simply write negative 3 because it has already been simplified in the first step, and then we can see x is bigger in the numerator, so we will solve it in the numerator. X 6 minus 3, y is same, y both has the same power 8, so they simply carried out and we get 1. We don't have to write it, but for the sake of it, this step I will write it. And the next one we have z, that is also bigger in the numerator, so we write z 12 minus 7 and nothing denominator, everything has gone up. Now we write negative 3 x cube z to the power of 5, and that is our final answer. Okay, we will do at least 3 more problems, and then I hope you will be perfect with the rules of exponents, at least in division. Okay, this is very simple one, doesn't take too long. Oh, yeah. Number 1 we have here is again 77 x has the power of 6, or we get 35 and y has the power of 8. So what is the answer? Well, this is the answer. As you can see, we cannot simplify these two numbers, right? and variables are different. They are not the same. In the numerator we have x, in the denominator we have y. So that is our answer for this one. Generally in your exams there might be some problem like this, but if there is, just keep it in mind. Don't mix up these two variables. They are different. One is x, one is y. Okay, and let's take a look at number 2. We have 3x square in parenthesis, then we have times 2x cube in parenthesis over 3x to the power of 4. Now how do we solve it? First we have to solve the numerator always. Okay, and they will be multiplied with this one, and these two will be multiplied with each other, and after all of that we will bring in the denominator. So I will explain this. First we have the numbers 3 times 2, okay, and then the variables. It has to be the same variable, not x with y. X with x and y with y. We have x square times x cube, okay, over 3x to the power of 4. Now we can solve it. 3 times 2 is 6 and x is 5. Remember, in multiplication we simply add these two together because the base is same, and 2 plus 3 is 5 over 3x to the power of 4. And now we can simplify it with the denominator as well. 3 times 1 is 3, 3 times 2, okay, and we get x. 5 minus 4, we get 2x, and that is our final answer. Remember, the subtraction happens where the exponent has the bigger power. It's bigger in the numerator, so we did it in the numerator. 5 minus 4 is just 1, so we don't write the 1, but we get 2x. Okay, let's take a look at this final example, and if you can solve this, then you are good to go with rules of exponents using multiplication and division. Okay, we have 9a square b times 2a cube b to the power 6 over negative 27. A has the power of 8 and b has the power of 7. Again, try at least the first step. Try to solve the numbers or whatever you can do with it, and then once you're done with the numerator, then you have to solve it with the denominator. Okay, so over here we get, first we will multiply only the numbers. We have 9 times 2, okay, this one right here, this one. Then we multiply only the variables that are similar, they are same base. For a square we have a cube times, and then for b we have b times b to the power of 6, and we simply write the denominator. We don't do anything with it yet until everything has been solved in the numerator. So for this one we get 9 times 2 is 18, okay. For a we get, again we simply add these two powers together. 2 plus 3 is 5, and for b 1 plus 6, that is 7, over negative 27 a to the power of 8 b to the power of 7. So now you can see the numbers. We can simplify it over here. We have 9 times 2 and 9 times 3, okay, and b to the power of 7, they are both the same in the numerator and the denominator. So we know that they are same. Anything that is same, 2 over 2, that is 1, right? So this also gives us 1. So now I will just write the numbers. Okay, let me erase this one right here. Okay, so we get 2 over negative 3. For the numerator a, we have a has the power of 5. In the denominator a has the power of 8. Now you can see exponent power is bigger in the denominator, so subtraction will happen in the denominator as well. 2 over negative 3 a to the power 8 minus 5, and we get 2 over negative 3 a cube, and that is our final answer. Okay, so if we got this right, you are good to go with the rules of exponents. Try to watch this video again with the examples provided and try to do it yourself. Pause the video and try it yourself. Okay, in the next video we will be learning the scientific notation and the negative exponents. Okay, what is the meaning of 2 to the power of negative 1, and that becomes 1 over 2. I will explain how this works in the next video. Until then, don't forget to subscribe and have a good day. Bye bye.